Hey everybody, it's Mrs. Thorburn, and we're going to talk about solubility. So this is your packet, and it is page 15, and we did take some notes here. So if you did not take notes, you may want to pause this video so you can copy down the notes. So what this graph shows is a solubility curve. So what I want to remind you of is that any point here on the line represents a saturated solution. And saturated solution means that we cannot add any more to the solution because the solution is full. If we add any more, then it's going to be excess. Okay? Anything below the line, any point here below our line, is called unsaturated. So that means if we add more solute, it will dissolve until we reach the line. Now, one question you may ask is, why does the line curve up like that? Well, it's because solubility has to do with the temperature and the grams of solute. So most solids, they do increase in solubility as we increase in temperature. So the example that I put here is if we have 70 grams of this fake solid, which has no name, and it's at 20 degrees Celsius, okay, we can dissolve 20 grams, okay, because that is where it meets the line. Now, if I had 70 grams of it, there was going to be 50 grams of excess because I can only dissolve 20. 20 is where 20 degrees Celsius and 20 grams meets the line. However, there's this really cool thing that's called supersaturated solutions. If I decide to heat this up like we did in our lab, okay, I'm going to heat it up. Heating is like this, we're increasing in temperature. Then my solution is going to become clear because everything can dissolve at a higher temperature. Then we're going to cool it back down very slowly, and it's back to a clear solution. If we decide to jar or disturb the solution, all this excess is going to come out. So you guys took a quiz and you had to explain, how do you know if a solution is saturated, unsaturated, or supersaturated? Because they all look clear. They're all clear solutions. If you have an unsaturated solution and you add one crystal, just one little piece, it is going to dissolve because you can add more. The solution is not full because we're below the line. If it's saturated, that means we're on the line here. If we add one crystal, it's just going to sink because we can't add any more. If we kept adding more and more, then we would have a whole bunch of excess. If it was supersaturated, that means it would be an unstable solution. So what that means is that everything would just go psh. All the excess solute, especially here, if we had 50 grams of excess, it would all come out of the solution, be really hot in our hands like it was in our lab, and then you would know it's supersaturated. So with one crystal of solute, tells you all those things. Okay, so if you go to the next page, this is our solubility curve practice. So how do we read this? The first question asks, which shows the greatest increase in solubility with increasing temperature? So what you want to do is look at the one that is increasing the most. You can dissolve more grams, okay, so if you look at this KNO3 here, you can dissolve more grams of KNO3 with increasing temperature. It has the greatest slope. The other guys here are kind of flat, some of them go down. I mean, NaNO3, it does get up to a higher point, but it's not increasing the most. So the answer for the first one is KNO3. Pink, what a great color, huh? All right, and then which ones decrease? We want to look for the ones that are going down, okay? So we got a couple here that are actually going down. So those are just some basic questions. So we got the CeSO4, and then we've got NH3. Some more questions that you need to know how to do are actually finding, like for number 7 and 8 here, what is the most NH4Cl that can be dissolved at 70 degrees Celsius? So what we're going to do is we're going to go 70 degrees, okay, and I want to know where 70 degrees meets my line at NH4Cl. So I go up 70, and here, over here, Sorry, that's not straight, but that would be 60 grams. And then similarly, if I want to know what's the most NaNO3 that I can dissolve, it's a lot higher, okay? It's all the way up here. And it is 130 grams. So which one of those is could make a more concentrated solution? Well, I could have 60 grams in 100 grams of water, or I could have 130. It seems that 130 grams, that's a higher number. So the NaNO3 is going to make a more concentrated solution. Okay, so these are pretty simple, just 1 point off the graph. If we go to the next page, they get a little bit more complicated. So we have to know, are these saturated, unsaturated, or supersaturated? So this is where we need to know below the line, on the line, above the line. So it says we've got 30 grams of KCl at 50 degrees Celsius. So I want 50 degrees and 30 grams. Okay, so KCl is this bright blue line. That is below the line. It's right here. It's below my line, so that would be unsaturated. You might ask, why are you writing in this weird gray blue? Well, those are the only options I have, sorry. Okay, now it says, now we have 30 grams of NaCl is added to 100 grams of water. Okay, so we got at 80 degrees this time. So 80 degrees, 30 grams of NaCl. NaCl is my awesome navy blue line. I do like the blues. Now that is still below my NaCl line, so it would still be unsaturated. Okay, now it says, this says we've got 30 grams of KCl3, and it says the thermometer is 25 degrees. No crystals are visible. Okay, so let's go to 25, and it says it's got 30 grams of KClO3 at 25. So that is right here. Okay, now this purple right here shows us, okay, the KClO3 at 25 degrees, only about 5 grams should dissolve, but 30 dissolves, and it says no crystals are visible. So what this means is that we've got one of these amazing super saturated solutions, because somebody heated it up, cooled it down, and it is still clear. Alright, now number 16 is a two-step problem, and I'm going to do this one for you, and then the rest of these I am going to have you do on your own. If you have any other questions, then you're going to have to come in seminar, okay? Or after school. You know I'm there on Wednesdays. So here we go. Alright, so a saturated NaNO3 is at 65 is cooled to 10. How many grams will precipitate out? Precipitate means how many solid grams are going to form. So we've got 65 degrees, and we'll switch to pink now. NaNO3 at 65 degrees is right here on this. Oh, hey, look at that. I can switch colors. Fancy. Alright, so anyway, so going to be purple, JK. Alright, so that starts at, we got 130 grams that we can dissolve at 65 degrees, because it's like right there. And then I'm cooling it to 10. Okay, 10 degrees would be right here. Okay, and that is 80 grams. So, how many will precipitate out? That means how many are going to come out of the solution. Okay, so it's like this right here. Sorry, not a straight line, but, you know, life goes on. 130 minus 80 is 50 grams. So, similarly, the rest of these are very, very much the same. And on this page, again, number 1, 2, and 3 are just looking at the graph, just one point on the graph. If it's asking us to make a saturated solution, where is that, everybody? On the line. Okay, so you want to go find 80 grams of KClO3 and find that. Where is it on our line? So, I'm sorry, KNO3, not KClO3. Alright, KNO3 right there. And that is at 50. Okay, so the rest of them are very similar. So make sure you get all these done. If you need to retake your quiz, please come in seminar or after school. And, you know, that's it for solubility. Stay tuned for the more exciting video on pH.